This exercise is from the first week homework of CIS Haskell course. Here you can see the exercise, and I will also put the link down in the description. This exercise is already broken in 4 smaller tasks, so we can start solving it right away. The first step is to split an integer into its digits, and this is the accepted answer from Stack Overflow. I will first write it down and then explain how it works. This is the solution, and now let's take a look what it means. Here you can see how this recursive function to digits breaks to its final form. So for example, let's take integer 1, 2, 3, 4, 5, and the division of 10 basically strips the last number from this integer, and modulus of 10, it basically takes the last number of this digit. So this is how it ends up forming recursively. Finally we will only have this empty list, and then we have this otherwise case for this empty list. And well, here you can basically see how the solution is formed. The next step is just to reverse this function. Notice that I never used this reverse function. You probably should have, but it wasn't required. So, but anyways, let's just write it down. So you could just do it like this. Take the reverse of the function we already wrote, but this is not the suggested solution. This one is. So what we are doing here is the you could say it's the reverse of what we did before. So we will first take the modulus of 10 and then recursively use this function to shrink it by taking the integer division of 10. The second step is to double every other number of this list. And first I'll just write it down again, and then we discuss. So this is one possible solution. It has 2 base cases. One of them is for odd arrays and one of them is for even arrays. So let's take a look at the double every other odd case. If you imagine some simple integer, let's say 1, 2, 3, and you plug it in, you can easily see that every second number starting from the right will be doubled. In this case, the middle one, and after that it hits to the base case where it just returns the same digit. And if you take the next odd integer with odd number of digits, then it would be like 1, 2, 3, 4, 5, and apply the same thing. It works. And now otherwise it's going to be even amount of integers, and here we basically do it the other way around. And now our base case, it always hits the empty list, which means that we only have to append empty list. You may reason it how you want. The next step is to separate all the digits after we have doubled every other, because once we double every other, then numbers larger than 10, and still we need to make them into a list which only have digits smaller than 10. So let's check how we can do this. What we are doing here is that we will take every single integer of the list, we will apply to digits function to it, and then we will use this append operator to append it to the list. If you are not familiar with fold or function, it's one of the most commonly used functions in Haskell. It would take quite some time to thoroughly explain it here. So it's if you're not familiar with it, you probably wanna take some time to just study this fold or function. But this is how you can do the separation of digits once more. Kind of flatten the list that we get from double every other function. And now we just have to sum all the digits we get so far, and we basically have to use all the functions that we have defined so far. So we will start from the beginning. By the way, this function, it will be defined as an operator, which means that we are not gonna explicitly tell Haskell that we are going to give parameter to it. Haskell will figure that out automatically. So first we will use 2 digits. Then double every other. Then separate digits. And finally we sum them all together. And now we should have everything we need to validate this credit card number. How you do the validation is that you just take modulus of 10 from this result of some digits function. So let's write it down and then test it out. What I meant to say that the modulus of 10 of this result, it has to be 0. This is said in the exercise. And now let's just set up the test. So according to the example, this should return true. It does. And this should return false. Seems to be working. So that's all for now. See you in the next video.